The question says that a giant refracting telescope at an observatory has an objective lens of focal length 15 meter. If an eyepiece of focal length 1 centimeter is used, what is the angular magnification of the telescope? The second question says that if the telescope is used to view the moon, what is the diameter of the image of the moon formed by the objective lens? The diameter of the moon is 3.48 into 10 to the power 6 meter, and the radius of the lunar orbit is 3.8 into 10 to the power 6 meters. So first question is saying that simply we have to find out the magnification of this telescope. So we know the formula for magnification. It is given by the focal length of the objective by focal length of the eyepiece. So after substituting the values, we will get a value of 1500x. Now the second question is asking what would be the diameter of the image of the moon given the radius of the given the diameter of the actual moon and the distance of moon between Earth, that is the lunar orbit or the orbit in which moon rotates around the Earth, that is 3.8 into 10 to the power 6 meter. So here let us revisit the ray diagram formed by the convex lenses. So if we see that an object is beyond the focal length, then height of the object is HO and height of the image is HI. So if we focus, so these are the two rays that I have shown over here. The first rays is parallel to the focus, parallel to the principal axis, so it will go from focus to the beyond, and then the second ray is towards the pole of the lens, so it will go unaltered, and the intersection will form the image. So if we focus on the two triangles over here, that is OAB and OCD, these two triangles are always going to be similar, and we know the property of similar triangle is that the ratio of the similar sides are always equal. So in this two triangle OAB and OCD, OA by OC will always be equal to AB by CD. So this question was asking what is the radius of the moon of the image? What is the radius of the image of the moon? So if we substitute the values, if we assume that this is the moon over here, now this is going to be the radius of the moon. So we can assume that AB is the radius of the moon and OA is the distance of the moon from the earth, that is the lunar orbit, and OC is the focal length of the objective. OC is the focal length of the objective, and CD is the radius of the image. So HI is the radius of the image. So moon will be forming like this. So we can assume like this condition, and from the property of the similar triangles, using this ratio, we can easily calculate the value of CD, that is the known over here, that is the radius of the image of the moon. So substituting the values, we will get CD equals to 6.86 into 10 to the power 2 meter. We will get a value of 6.86 into 10 to the power minus 2 meter. So we can easily calculate the diameter of the moon now. So diameter of the moon would be equal to 2 times CD, that is 13.7 centimeter. Thank you.